Hello and welcome to CCNA Subnetting Video 6. This is the sixth of 8 subnetting videos that are included with both the ICND1 and ICND2 official exam certification guides from Cisco Press. This video, as well as subnetting videos 4 and 5, show an example of how to find the broadcast address of a subnet and the range of assignable or usable addresses in that subnet. So this is the third of 3 such examples. This particular video shows how to find the broadcast address and range of addresses for subnet 192.168.1.144 with mask 255.255.255.240. The first objective for this video is to examine a particular process for finding both the subnet broadcast address and range of valid addresses. This video picks up the same problem that was begun in subnetting video 3, which showed how to start with an IP address and mask and find the subnet number, with this video now taking that subnet number and finding the subnet broadcast address and range of valid addresses. And as with all these subnetting videos, the strategic objective is to help you prepare for the CCNA exams so you can do subnetting questions quickly and with confidence. For easy reference, the screen now shows a copy of the text of the process that will be demonstrated in this video. Notice that this process starts with step 5, and it's numbered this way because the associated process that finds a subnet number has 4 steps, so this process just picks up where that other process stops. Feel free to go back and watch subnetting video 3 at this point. However, a brief review of the results of that video may be all that you need. Subnetting video 3 started with an IP address of 192.168.1.150 with a mask of 255.255.255.240. That video also showed that the 4th octet would be the interesting octet, and it calculated the magic number of 256 minus 240, or 16. Next, to find the first IP address, last IP address, and broadcast address in this same subnet, we start with a little bit larger table, just with space to write down the answers. Now, as you can see here, at the first step to find the broadcast address, you look for any octets to the left of the rectangle, and then copy down the subnet number's value into the broadcast address. In other words, the subnet number's value in the octets to the left is the same as the broadcast address value in the octets to the left of the interesting octet. Then at the next step, 5b, you look for any octets to the right of the rectangle, which of course there are none. The interesting octet is the 4th octet, there's no 5th octet, so you don't really need to do anything at this step. So at this point we have a broadcast address of 192.168.1.something, and now comes the tricky part. To find that last octet, we take the subnet number's value in that interesting octet, the 4th octet in this case. We add the magic number to it, which gives us 160, then subtract 1, which gives us a value of 159. So the broadcast address in this subnet is 192.168.1.159. Although the math is very obvious, I'll go ahead and show how to find the first IP address and last IP address in the range of addresses you can assign in the subnet. To find the first IP address, you copy down the first 3 octets of the subnet number, regardless of where the interesting octet is, and then add 1 to the 4th octet of the subnet number. In this case, of course, 144 plus 1 is 145, giving us a first IP address of 192.168.1.145. Next, at step 7, the process finds the last IP address in the range of assignable addresses in the subnet. At this step, you copy the first 3 octets of the broadcast address into the last IP address row, and then you subtract 1 from the last octet of the broadcast address. In this case, that's 159, so 159 minus 1, of course, is 158, giving us a last valid IP address of 192.168.1.158. This video concludes the third of 3 different examples of how to find the broadcast address in the subnet and the range of valid addresses in the subnet. The next step, of course, is to practice the process until you master it. As usual, you can always use the practice problems that are in Appendix D of both the ICND1 and ICND2 exam certification guides. Hello, and welcome to CCNA Subnetting Video 7. This is one of 8 videos that are included with the ICND1 and ICND2 exam certification guides from Cisco Press. This video shows how to find all subnets of a classful network, assuming less than 8 subnet bits. The example in this video uses Class B network 128.200 with a mask of 255.255.224.0. This video focuses on a particular process to find a few things about a network number. In particular, this process shows how to find all the subnet numbers of a single classful network, as well as identifying the two subnets that are special, the zero subnet and the broadcast subnet. A broader goal for this video is to be part of a package that helps you learn how to answer CCNA subnetting questions, in particular to teach you how to answer those questions quickly and with confidence. This particular video shows how to find all the subnets of Class B network 128.200.0.0 using mask 255.255.224.0. Once you finish watching this video, your job is to practice. The process you see in this video just gives you structure so that you can begin to learn through practice. Once you practice enough, you can internalize the process. For example, if you were to multiply two three-digit numbers together right now, you wouldn't think about the process. Likewise, by practicing this subnetting process enough, you'll see the patterns, you won't have to think about the process, but you'll still be able to get the answer. The Cisco Press CCNA exam certification guides, as well as some other Cisco Press resources, refer to a one-page summary of any single subnetting process as a reference page. The books explain three different variations of processes that can be used to find all subnets of a classful network. For example, reference page 7a is a process that shows how to find all subnets of a network assuming less than 8 subnet bits. RP7b assumes more than 8 subnet bits. There's even a third process described in the books that we didn't bother to name that assumes exactly 8 subnet bits. This video shows an example of how to use reference page 7a's process, whereas subnet video 8 shows an example of how to use process RP7b. Now the video image shows the full RP7a process as found in the CCNA exam certification guides. This video is not intended to go through each of the steps generically, but instead to show an example of its use. However, I included this copy of the process inside the video so that you can note the time of the video right now and come back here to review the generic process. Next, let's take a look at the example. In this example, we'll use IP network 128.200.0.0, which is a Class B network, and mask 255.255.224.0. That means there are 16 network bits because it's a Class B network, 3 subnet bits, and 13 host bits. Now in process RP7a, the first 4 steps occur only once, and step 5 is then repeated. So taking a look at the first 4 steps, first we see that we simply copy down the mask into the top row of a table. Then at step 2, we put a box around the interesting octet. Once again, that's the octet in which the mask is not a 0, nor is it a 255. At step 3, you calculate the magic number. The magic number is 256 minus the value of the mask in the interesting octet. In this case, 256 minus 224, or 32. Finally, at step 4, you just write down the classful network number, which is also the exact same value as the 0 subnet. Next, to find each successive subnet number, you simply keep repeating step 5 of this process. In step 5, you start out by copying the 3 boring octets, the ones that are outside the box, down to the next subnet number. Then you add the magic number to the previous subnet number's interesting octet's value. Now visually, you just take the magic number 32 that you see there, add it to 0 in this case, which gives us a value of 32 in the interesting octet of the next subnet number. So as you see here, the next subnet number is 128.200.32.0. To find the next subnet number, you simply repeat step 5. So at step 5a, you copy the 3 boring octets down to the next subnet number's line, and then at step 5b, you add the magic number of 32 to the previous subnet number's value in the interesting octet, which is 32 in this case, for a value of 64. So the next subnet number is 128.200.64.0. Repeating step 5 again, we copy the 3 boring octets down to the next line in the table at step 5a. And then at step 5b, we add the magic number of 32 to 64 in this case, which gives us 96 for the new subnet number. So this next subnet number is 128.200.96.0. At this point, you should start to see the pattern. Of course, in the third octet, all the subnet numbers are some increment of 32, which is the magic number. So going through the rest of these subnets briefly, for the next subnet, if we add 32 to 96, the next subnet number's third octet is 128. For the next subnet, the third octet's 128 plus 32, or 160. For the next subnet, the third octet is 160 plus 32, or 192. And yet for the next subnet, the third octet is 192 plus 32, which is 224. Now we're close to the end of the table, and as you might guess, we're almost to the end of the process. At this point, we just keep repeating the process, copying the 3 boring octets to the next line, adding the magic number of 32 to the previous subnet number's value. In this case, we get a value of 256 as this last subnet number. Now, even if you didn't know much about process RP7A, you'd probably think that the value of 256 is a strange number in an IP address or a subnet number. Normally, you'd expect to see numbers between 0 and 255 inclusively inside a dotted decimal IP address or subnet number. As it turns out, step 6 of this process uses the fact that we add up a value equal to 256 as a reminder to say, stop the process. So here at step 6, notice it says that 256 is a value that's out of range, so let's not use that subnet number. In fact, in this case, we'll just put a big red X over it. Then, the previous subnet that we had calculated, the one that ends in 224.0 in this case, happens to be the broadcast subnet. So that completes the example of how to use process RP7A to find all the subnet numbers. Now you can remove some of the clutter from your workspace if you like, and you can even write down the numbers as dotted decimal numbers as you see here, noting always that the 0 subnet is the smallest number of these subnet numbers, and the broadcast subnet is the largest of these. Now as you see here in this particular example, there are 8 subnet numbers listed, and it's a good reminder to think about how many subnets are listed because, as we said earlier, there are 3 subnet bits, so we should expect to see 2 to the 3rd subnets at the end of this process. This completes subnet video 7. At this point you should practice, as usual, using Appendix D in the ICND1 and ICND2 exam certification guides. It's particularly important in this case that you go ahead and practice now rather than watching the next video, because subnetting video 8 relies on the process shown in this video, so practice this process first and then move on to video 8.